What's up, guys? This is Pierce from SnappyData, and today I'm going to show you a new demo we've released that runs over the NYC Taxi data that was recently released. The full data set's from January 2009 to June 2015. It's about 1.1 billion individual taxi trips. In this demo, we use just the year 2013, which is about 150 million records. The demo is running in SnappyData iSight, which is a tool for instantly visualizing queries over SnappyData. We'll talk a little bit more about that later. And this demo is going to show essentially running the full query over all 150 million records, as well as running the same query on a sample table. And we'll be noting the latency difference between the two. Sample tables run in our Synopsys data engine, which we'll talk a little bit more about later. So this demo also loads the Spark UI and Pulse, which is a management and monitoring tool for SnappyData. It's running in AWS right now on a single node. So the first thing we do to load data is create an external table, which is essentially a table pointing at a set of Parquet files in S3. We've also created a sample table, and the way that works is we pass it a query column set. So those are the columns we want the sample table to stratify on. Here we're stratifying on pickup underscore date time, and we're asking for a fraction of 1%, which means we want it to be 1% of the size of the original data set. We also create a sample table on hack license. You can see it's the same here. And just I've already run this pane to load data, and just to see the difference, these Parquet files represent about 10 gigabytes. The sample tables, as we're looking in the Spark UI here, they're around 200 megabytes, so they're much smaller, take up much fewer resources. So the other thing I've done is here's the schema if you want to run any of your own queries. But the other thing I've done is I've run these count queries already, and as you can see on the full table about 150 million records, on the sample table about 1 million. So let's just get into it. The first analytics query here is the number of rides per week. So we'll go ahead and run that. And if it blips here, it's because I'm just cutting out the query execution time. I'll continue to do that throughout the demo. Okay, so that just finished. As you can see, it took about 26 seconds. The graph is the result here with the number of rides on the left-hand side and the week of the year along the bottom. Now we'll run the same thing over the sample table. The only difference is this little clause with error 0.1, where we're basically telling the query engine we're willing to tolerate a 10% error in the answer. So we'll go ahead and run that. That returns in about 3.2 seconds. And the important thing to notice here is if you look at the two graphs, they're almost identical. So you get a huge speed up, and it's running over a table that's much smaller, but you're getting almost the same answer. And if you were to make a decision based off of this graph, it would definitely be the same decision. So let's go down to the next query. What are the worst times of day to take a cab from Midtown to JFK Airport? Go ahead and run that. Okay, so that query just finished. As you can see, it took about 81 seconds, and the results are here. You can see the time of the day by hour along the bottom and the total trip time along the left side. So now we'll go ahead and run it over the sample table, and before we do, note this little directive, show instant results first. So what we're telling the Synopsys data engine is run it over the sample table. As soon as that's done, run it over the exact table, and I'll decide essentially if I like the sample result, or I'll just let the full execution go. So as you can see here, it took about 3.7 seconds, much faster than this. And let's say, okay, I'm happy with that result, then I'll just cancel the full execution, and I'll stay with the sampled result here. Again, as you can see, the graph is very similar, and you're getting a huge speed up. It really helps. In this time frame, it's very easy for your mind to wander um, and get off task, whereas here it's much more of an interactive time. So now I'll skip down to the third query here. How does ridership change over the months? So we'll go ahead and run that. Okay, so that just finished. Took about 24 seconds. And here's the graph at the bottom. You can see the riders on the left side and the month on the bottom. Now we're going to run the same thing over the sample table, and the new feature we're showing here is this behavior clause. So here we're telling it to do nothing, but you can for example tell it to once it's done rerun on the full table. You could say do a partial rerun on the data that had the most error, for example. So there's a lot of different options for what you can do with this little behavior clause. So we'll go ahead and run it. And there's your result. It took about 3 seconds, and again, the graphs are very similar. So there's a little more to this demo, but I'll leave it up to you guys to come check that stuff out for the sake of time. Let's now take a look at this little architecture diagram, sort of describing what's happening. So you can imagine, a query comes into this SnappyData iSight, which is running in the cloud, and essentially the query engine decides, okay, can I meet the error that the user has specified? And if it can't, it'll send the query back to, say, the data lake, wherever the exact data files are. They could be in the cloud, they could be on-premise. If it can, it'll go to the samples and obviously give you an interactive result very, very quickly. And of course, we're showing with this knob here that the error can be tuned by the user. And one thing to note is, if you're just having these samples in the cloud, as we showed earlier, the sample size is very small compared to the original data set. So, you're not actually using that many resources like you would be with your full data set here. And so you might also be saying, okay, well, this demo could be totally doctored. I'd like to run it myself to actually believe it. You can run it yourself. So all you have to do is go to snappydata.io/cloudbuilder right here. There's a little how-to screencast with how to get it all started. However, all you need to do is fill out this form, select an instance. 2 clicks later, it takes you to Amazon CloudFormation, where you'll eventually see the stack finish creating. There'll be an Outputs tab with the URL to your Zeppelin instance, which will look like this. You'll just click on NYC Taxi Analytics, and you can run all of it yourself. We hope that you'll try your own queries, and we also hope that you'll come and give us some feedback. Note that we do have a short survey at the end, and we'll randomly pick a winner for an iPad just in time for Christmas, so please check out the survey as well. Come to our community and give us some feedback. We look forward to hearing from you.